What's going on, everybody? It's your boy JT Knows Things, and we are back in the Crypto Den. Today, we're actually going to switch gears a little bit and go to the crypto classroom. All right, at my partner's place, Steve Wolterman. We are meeting every week and filming a podcast. So we're going to publish the audio version on every platform: Spotify, Apple Podcasts, you name it. Crypto Classroom will be there. Your boy will be explaining in long form all the fundamentals that have made me successful in the space, and teaching my partner Steve along the way as to what the hell is crypto and what are we doing with it. This is the episode. I just wanted to pop right in and introduce it. It's very exciting. I hope you learn something valuable. At the bare minimum, you become a better investor today than you were yesterday. Thank you so much for your love and support, tuning in, watching this, listening to it. Whatever you do with it, may it bring you a different level of sophistication. Peace and love, guys. Until next time.
Crypto Classroom. We're your co-hosts. I'm Steve Wolterman. This is Jake Tullis. Sometimes we'll call him JT. Together, we are part of a company, Bleeding Edge Capital. And Bleeding Edge Capital is a GP and a crypto hedge fund. About a year ago, I met JT. My background, I have a small law firm. I'm an attorney, practicing mostly business, tax, and real estate. But I met JT, became fascinated with crypto, convinced him to put together a fund, and we've done such, and on our way now. With regard to that fund, I'm responsible for legal and operations, but JT is the head of all strategy, makes all the investment decisions. And this podcast is not about the fund, but is rather educational. And I know a lot of people that I talk to, I feel like are me, who want exposure to crypto, want to learn about it, but where do you start if you don't have the software expertise background or a technical background? So over the last year, just everything I've learned from JT, we're going to try to recreate some of these podcasts and be able to ask questions and have him educate us. I think a lot of people, as I said, like me, will find a lot of value in this.
Hey guys, before we get into the episode, I want to remind you that we are a discretionarily long fund. That means the time frames or time horizons that could be referenced in this episode, the shortest period would be 3 months, and at most we're talking about 5 years here. So when you hear about a new development or trying to understand the fundamentals we discuss in these episodes, just relax and have the perspective that this will not play out for an extended period of time, and you have time to do something about the information you learned here today. And speaking of that information, some awesome disclosures. We are not financial advisors. Nothing in this episode or any other episode you may hear from Bleeding Edge Capital could be construed as financial advice, life advice, or any other form of advice. We are simply here for educational purposes.
All right, welcome back to Crypto Classroom. I'm Steve Wolterman, Jake Tullis here.
Guys.
We just did an episode on Chainlink and talked about, right now some exciting stuff with that asset. We had mentioned in that episode, Jake had mentioned the concept of zero knowledge, and we thought we would just jump into that for a short episode here. So podcast number 10, we're going to talk about this relatively new concept of zero knowledge. And I'm going to let Jake kind of take us into that.
Yeah. So first, I would say it's not actually new. It is new to us, but in the computer science field, it's been, I guess, a science fiction idea for a long time. Similar to that episode with Corey talking about the space economy and all this futuristic stuff that we discussed. Like, crazy to think about that we live in a time where it's kind of relevant. Like, that's happening. Zero knowledge falls into that sector of crazy sci-fi stuff that is like now actually real and happening. So I would say that we broke ground on zero knowledge sometime in I would say spring of last year. And it started in crypto, like blockchain companies, specifically Matic, which is why I love Matic. I love Polygon. The team's amazing. But they really did break the kind of cryptographic seal of what it is. And I know this all sounds really intimidating. What you can think of really is just a method of reducing file size. That's all zero knowledge really is.
So that would be important when it comes to storage.
Storage of any file.
And speed, perhaps?
Yes. Storage and speed. The reason why I believe its advent or invention really happened in blockchain is because there's only three real ways to impact or influence or improve a blockchain, right? We need to get more stuff on chain. So you either have to increase the block size, increase the speed of which it processes data, or in what we're doing with Ethereum, kind of split it up to optimize each area, essentially. Or reduce, I guess there would be a fourth way, that would be reduce the amount of data that can fit inside of that block. That would be the other way to kind of grow a blockchain. Yeah. To where we can scale it to 1 billion users, right?
Which again kind of hits on storage and speed.
Yes.
Which probably most people, Web3, Web2, in my world, whether it's downloading, files or sending files, there's space issues. You can't send files that are so large. Sometimes things take a long time. Sometimes you're waiting 12 minutes for your computer to,
uploading these episodes.
Right.
These are usually 2 gigs.
So this is, an underlying mechanism that's going to help all of computer science.
Yeah.
Okay. Web3, whatever it is.
Yeah, exactly. Whatever it is, it's definitely helping. And in fact, it's really relevant in crypto because now it's so fast, so it's the bleeding edge, right? Yeah. It's so competitive. There's over 30 zero knowledge layer 2s now, but I mean, in about 5 years, everyone will appreciate it. They'll know what it is and everything else, but it really will be used by any tech company. And the basic concept, I have a really good example. So let's say we're computers and we have specific jobs. There's actually a third computer, okay? We all have different roles to accomplish this task. I'm the prover. You have, let's say, the customer. And then you're the person that validates, okay? Now, I'll come back to that in a second. Let's just say the task at hand is to find a Waldo penguin on a 12 by 12 piece of paper. We're computers.
A Waldo penguin?
Yeah, like there's 1 million penguins on this 12 by 12 image.
Where's Waldo?
Yep.
Okay.
1 million of them.
Yeah.
Right? You have to find the Waldo one. And you only have, let's say it's a block time. You have 13 seconds to identify the penguin that has the Waldo cap. You as a computer are going to have to look at every individual penguin sequentially.
In our 3 computers, which one's doing this?
You're going to be doing this. You'll be the computation.
I'm the validator.
You're the validator. You're going to have to find Waldo. You have 13 seconds to scan every single penguin and identify the one that is different out of 1 million on a 12 by 12 piece of paper. Zero knowledge. And up until now, the only way for you to do that job, up until zero knowledge, was to, like, that person submits the image, you have to compute and then give them the answer. Oh, it's penguin 848626. There you go. That's what the customer wanted to know. You scanning each penguin is a computation. And then the result, the penguin ID number, would be like an actual ask that you would have for a computer to do.
So is this analogous to how computers?
Yeah. How they kind of just work together, right?
So yeah, I don't want to take you off track.
Yeah, you're getting it's important that everyone understands it. Yeah.
I understand, that seems like it could take a long time and not the easiest thing to find out of 1 million on a small space.
And in blockchain, you have 13 seconds.
So like in any kind of transaction between two computers, like
What are we talking about? Like the real?
We're talking about someone on a, like, say, Amazon,
Yeah.
putting in an order to a product. And then you're the computer that has to realize where their location is, where the person that sold it is, where the inventory is, when it's going to be delivered. To give them, you got to do all the computation to tell them, hey, your package is arriving at tomorrow between 4 and 6 p.m.
Okay.
That's the computation of reading the penguins.
Okay.
Right? So you have a user request, you have a server response, and for that response, an API is usually set up. It does a lot of the computation, and then you spit out the result. Tell you
API again.
Application programming interface.
Okay.
If Amazon, yeah, I mean, we don't have to get into that, but that you can just think of that's basically what's happening.
Okay.
So you have this image. Your job is to compute it. Now, if this is in Web3, that would be a user saying, I want to, I don't know, let's say I have 5 transactions I just did. You need to validate and get consensus that they're all correct and they all happened, and maybe they were on 4 different networks and 3 tokens. There's a lot for you to figure out. And you only have 13 seconds time to finality to.
Well, why is that?
That's just how blocks are. If you want to get
they get filled up within 13 seconds.
Every block, new block, 13 seconds.
People are firing
Correct.
questions, looking for responses, and you're putting all this into blah blah blah.
And there's a queue. That's why there's gas.
Yeah.
Right. So if there's 10,000 transactions submitted to be validated to the Ethereum blockchain, there's going to be an order because computers are sequential. The same way you read that image, penguin 1, 2, 3, you're going to read it sequentially until you find one that is different with a different attribute. Yeah. So now that we understand like computers messaging, because that's really what that is.
Yeah.
Zero knowledge is like you throw in a third computer. That's me. I'm going to be the prover. I'm going to do all the computation before you get asked to find the penguin. Let's just say there's a sequence to these events. And then I find it. Okay. And then when I find the penguin, and we don't care, there's no time.
How do you know to find the penguin if the request has to be?
It doesn't come to you. It's coming to me, the prover. See what I'm saying? So like Ethereum has a layer 2, that's me. I'm the prover. Ethereum's the one that normally was doing the execution of these computations. We built a layer 2, that's me, that does this now.
They outsource it to their.
Yes, they outsource.
Yeah.
Well, they outsource all the execution and computation to a different thing. And then all you have to do is validate, well, I'll get there. But you have a different role now because of zero knowledge. There's this third computer called a prover. And I'm going to do it off chain on my own. I'm just going to be running this computation. Doesn't really matter how quick or how slow it is because this user doesn't really care. It's not time sensitive. They just know by the end of the day it needs to be on the ledger. That's it. In this scenario. So I find the penguin, then what I do is I basically take a 12 by 12 piece of paper above this image. Right? So now we have 2 pieces of paper. Under the second image, there's just a little hole cut up. And it has the answer, Waldo Penguin is here. And then I submit, I show you the fact that that is the Waldo Penguin.
Yeah.
Right? Because now I've blocked out 999,000 other penguins. And I can just show you that this is where Waldo is. And if I've shown you that that is empirically true, I can just submit to you the top piece of paper. That's called a proof. And then now you know that this computation was done and is correct. And I just reduced the size of images they have to process by 999,000 in this example. Because I can prove, I have a proof, a mathematically accurate proof that can be wrong if it is not correct, that you can validate. It'll take you an order of magnitude less time. And you'll be like, yeah, that transaction or that bucket of transactions all happened correctly. And I'll just store the proof to those transactions. So what we've done is reduce the amount of the file size that we have to submit to Ethereum by a lot. That's how it works in theory. I'll give you an example.
Yeah.
Polygon has a zero knowledge layer 2. What they do is they bundle transactions. So if you deploy your project on Polygon instead of Ethereum, What you're basically...
Just, I don't know if you said that. I know
No. This is for the audience. Yeah.
Yeah, just, again, I often think of, my dad or other people like
Yeah.
layer two again. I mean, I know we're taking steps back, but layer two, tell us again. That's,
Yeah. Layer two is just, it's basically like off taking. Okay, well,
in my own words, I understand it. It's like if you've got, NetSuite, from Oracle that a company wants to install, but it might not fit perfectly. You've got other companies that come in and will create software to make the two compatible and work together. So it's like a secondary level.
that would be more like APIs and integration work. That's what I do. I went to consulting. Yeah.
Tell me.
But no. I mean, that is where, I mean, interoperability, integration is my specialty, and that is what our fund is about. So I mean, that's a good idea. Just layer twos are more like a layer one right now, like on Bitcoin.
Yeah.
It does all the computation. Meaning, if I send you 1 Bitcoin, it's going to validate both of our wallet addresses. It's going to do everything. After it does all the computation, execution, it also will store it on the ledger.
Right.
And it's all happening at the base layer.
Yeah.
Layer two is basically taking some of the responsibility of that network and then putting it into a different bucket of code, a different project, a different thing to basically free up the layer one infrastructure.
Okay.
So Ethereum had to do everything. And then Polygon came around and it's like, hey, I'm only going to store my data with you. I'm going to do all the execution. That way we're both faster. It's called optimizing. The more optimized software is in computer science, the better it performs. That just makes sense, right?
Yeah.
So a layer two thing is basically taking responsibility, computational responsibility off of Ethereum.
Okay.
Essentially. So
not just Ethereum, but
right. Thank you. Yeah, any blockchain,
right,
in general. So what you have now are layer twos that have zero knowledge proving systems. So let's say that Polygon let's say they do 30-minute bundles, okay, or batches is the actual term. So in that 30-minute window, let's say they have 100,000 transactions. If 100,000 transactions happen on Ethereum, again, just to really drive this point home, Ethereum every 13 seconds would order so every 13 seconds inside that 30-minute window, there would probably be, I don't know what the number is, maybe 110 blocks or something. And then it would have had to move through every single transaction sequentially. And then you'd have to pay gas and wait a long time for that many transactions to finally get yours processed. You do this on Polygon, it'll process instantly because they're not needing to they're not needing to have it validated and reach consensus yet because they're not submitting it to a block. In this 30-minute time frame, they're just going to keep building transactions until they're batched.
So it might still take a little bit, but once it's submitted, it's instant.
Yes.
Right.
And they're building it up. You agree as a user to some redemption.
Yeah.
Like, okay, I'm accepting the fast transaction speed.
Yeah.
But I understand if my transaction is fraudulent, they will rake it back. Because in that 30-minute time frame, it's doing the computation. Remember, I told you the time was not a big factor for me as the prover in our little example.
Right.
This is how it's not a big deal.
Right.
The user will say, I want to swap Matic for comp. And then if it's on Polygon, that'll happen instantly. But they also know that there is some redemptive qualities there if they're a fraudulent actor.
Yeah.
Right? There's going to be fraud proofs that are implemented to make sure these transactions are legit. Because they have a zero-knowledge prover working through this batch of transactions while they're building.
And you said before, and I don't recall if we've covered this on our podcast before, but the concept of gas, I'm sure is probably confusing, or a lot of people might not be familiar with that. But
yeah,
it's sounding like are you paying gas? Your transactions more expensive the more people that are trying to transact within that block, or the more activity that's going on at that moment, you're going to have a higher fee of some sort.
If you want to change your order in the block.
If you want to
It's called block ordering.
You want to expedite.
Yep. You can expedite the transaction.
Okay.
Because those blocks are produced every 11 to 13 seconds.
Yeah.
And you might be transaction 24,000. And that's going to take like 3 to 5 minutes to move through. Right?
Yeah.
If you pay an extra 40 Gwei, that breaks down into a certain amount of ETH. It's a unit of ETH. It's a small unit of ETH, like a Satoshi for Bitcoin, essentially. Yeah. But anyways, like you're going to pay more, but you would get your transaction moved up if you're willing to. It's like a bidding or an auction system. That's one of the theories.
Yeah, point. If I'm on an auction site and I'm bidding on something, I'm hitting refresh, and I'm hoping to use, Bitcoin or ETH or something as my currency.
Yeah.
Is that a fair example of
right now with two? Yeah. You can pay the gas. You can just slide a scale and get to the top if it's that important to you.
Yeah.
Yeah. Right now, Web 2, you're stuck refreshing until you catch up.
Yeah.
Web 3, you're like, I want it done now, so I'll pay top tier gas.
Which might be dollars.
Yeah.
Even on a big transaction.
Oh, it could get expensive.
Okay.
Like $100, $200.
Okay.
If like in the peak of the bull run with Ethereum's 12 transactions per second throughput, yeah, we're talking $150 to get something done instantly. And that's why we have a fund investing in infrastructure to scale these things, because they're not usable yet.
But what zero knowledge does is, I get it, it frees up space and makes it quicker to validate, but it doesn't. Does it solve the problem if you want to be bumped up the, because there's
let me get there. Yeah, let me get there.
Okay, sure.
So as these transactions, going back to this example, they're building up in a batch. Every 30 minutes, Polygon will submit 48 things in a day, right? 30 minutes, you get it. So let's say they have 100,000 transactions. At the end of that 30-minute window, the prover that they have is going to be able to produce a proof, like that top layer of piece of paper, that it can then give to Ethereum. And Ethereum will just run the proof cryptographically, do some math, basically.
Yeah.
And be like, these 100,000 transactions are all good. And then it only stores this proof. This proof could be 1/1,000,000th the size of this 100,000.
Yeah.
Right? So if a block can only store 64 megabytes every 13 seconds, 100,000 transactions could be a gigabyte. Like it would take a lot of blocks to move this.
Yeah.
Then you think about everyone paying gas and competing. We're talking minutes, maybe 10, 15 minutes to actually just store it all. Right? This one proof could be 1 kilobyte, or like.
I get that. I get that. Like
it's a compression technology.
On the chain, we've compressed it.
Yes.
We've done awesome things, but from the user standpoint, if I'm sending a request or I'm trying to make a transaction, and maybe time, because we said before, time wasn't important as long as it got on the chain that day. What if it is important? There's still time for the prover that's off chain, right? So
the execution happens at a different time frame than the storage. So what we're talking about is just storage.
Yeah.
Execution still happens instantly. There's no ordering of execution now because we've separated execution and storage with layer 2s. So they're freed up to just execute. As fast as that bucket of code can pump out results, it will. So you're going to execute faster.
Okay.
And basically the redemptive quality. So you're going to get way faster results. In the same example, it would take seconds for you to put in a buy order on that eBay site. Right? Mm-hmm. No gas. You just put in the order.
Yeah.
Goes through. Everything happens. Okay. That transaction is put in this batch. Then this prover makes sure the transactions are good. Then it runs a fraud proof to make sure that it was not a fraudulent transaction. Like you did some kind of node. There's a lot of different ways, but you can make sure it's legitimate. As that's going and moving through these transactions, the user's already, they're off to doing something else. It's 22 minutes later. Like they're done, right? They're watching Netflix. They're doing whatever. I don't know. And since it wasn't fraudulent, it's fine. After 30 minutes, it's going to get.
So it doesn't matter that this part of it happens after the user has sent they click the button, it happens, and then after the fact, it gets proven and then validated and added to the chain for, you know, purposes of
All the exciting things about blockchain.
Right.
It's on the ledger.
So this would be akin to buying something like on eBay, and you think you've won, and an hour later it comes back and says, "Hey, we had a problem processing your payment or validating your account. We've pulled this item from your winning bucket.
Yeah.
Yeah. So
it's just going to have a redemptive quality.
Yeah.
It's
So
like
you're not sitting there with a computer spinning while
Right.
it gets proven.
Right.
Okay.
Yep.
Got it. So that sounds fairly profound.
It's very profound. Not only that,
Because that will help
everything.
Everything.
In fact, there's a business being built, an industry being built of no different than like Bitcoin miners, people that are creating proving stations.
Yeah.
So they have hardware that are optimized to create zero knowledge proofs now. You plug them into the wall, you go to a software and you offer proving rates, and you get paid per proof you produce. And it does not matter what computation you did.
And anybody can.
Yeah, you could have proofs to reduce the storage of real-time game data for like Call of Duty, because that game no one thinks about it, but like a bullet missing or hitting an object in code, that's a thing. And then you have an accuracy, you have a spread, which is all degrees of probability, an algorithm running when you click the button to shoot. And then you also have the kill to death ratios, how long the match was, where they were at. I mean, the amount of data they capture to make it a competitive game is a lot of computation.
Yeah.
It's very expensive to store that data. But they could have it all being run in batch and being just submitted as a proof to their server. It would reduce their storage cost by 99%.
So is there a leader in the market today that's out in front with?
This industry is less than a year old.
Yeah.
So I mean, there's no big anyone. Polygon's probably has the largest zero knowledge Ethereum virtual machine. It's called a ZK EVM. If you guys are reading about that and you see those letters, that's what this is. It's just that layer 2 example we spent the past 10-15 minutes talking about. That's what ZK EVM is.
But
they have the largest.
Yeah.
The most transactions, the most value.
But there's no single project that developed zero knowledge.
No, this is a cryptographic discovery. This is like a gift from the research gods.
Interesting.
Yeah. I mean, it's just no different than AI. I mean, OpenAI was the first to market with a chat GPT.
It's like stumbling on a different methodology.
Yes.
Like almost like, like line manufacturing. Like,
yeah.
Right.
It's a different way.
Assembly line, assembly chain, yeah.
Correct. Yeah, it's a different way of doing data storage and data compression.
Yeah.
And that's a massive problem you have. Like, think about, I can tell you right now, my TikToks, they're 60 FPS frames per second for the folks at home, and 4K. That's very high quality.
Yeah.
30 seconds is 200 something megabytes. Apple is storing that. I'm uploading it to TikTok, to Instagram, to, you start thinking about the foot trail. I got literally copies that total 2 gigabytes, and I post 3 a day. That's one guy out of hundreds of millions. I mean, we're talking the amount of data and the amount of money going into data storage is insane. It's in the trillions. And this new method is going to reduce, or I guess just increase how much data we can pack into the same storage. 6 gigabytes of zero knowledge proofs would be like, I don't even know, petabytes, like thousands of petabytes. It would blow your mind. So the compression technology is it's out of this world now. And the reason why it really matters for blockchain is because that problem we talked about, like the only way we scale blockchains is by increasing block size, reducing the data that we submit to a block, or increasing how quickly we can process blocks.
Yeah.
It's really it. Or modularizing it out like with layer 2.
This is a big step forward.
Massive step forward. It's changed. This is another development that has changed our allocation. Like at first I was so bullish on Matic. But now with the zero knowledge development and the advent of it, there are almost 90 layer twos that offer zero knowledge proofs. Even though Matic was the first, since it's open sourced and decentralized and everything, now everyone has zero knowledge. If you don't have zero knowledge, you're just behind now. They started that precedent. It's incredible.
So either it'd be more difficult to pick the winner, or there might not be a winner. It might just be
I think the only winner is Ethereum on a long-term horizon.
to benefit from it.
Because they all use Ether as money. If I
Will
build,
zero knowledge apply to other blockchains?
yeah, it's just a methodology they'll start
Yeah.
using. And there might be companies that come out with infrastructural plays where they're like, hey, we have a new zero knowledge oracle where basically we'll submit proofs to all the weather data for your. So instead of it being a direct data feed with a lot of computation to get into, for that farmer example
Yeah.
from last episode, like right now that could be petabytes of data needing to be processed
Yeah.
to get all these smart contracts in sync with the weather of.
Yeah.
But now we could have an oracle that does all of that, has a proving station hooked up, and then just submits proof of the data.
Yeah.
So now that could be a very feasible application that is scalable to 100 million users because it's just proofs now.
Yeah.
And all that computation is being batched and done and submitted as a proof.
Fascinating.
It's the applications of it is so broad. I mean, it'll be everywhere. I mean, but again, it's one of those things that very few people care about. But
Right.
like,
I mean, it's
but
yeah,
it's
it's in the weeds a little bit, but I mean, it's overall, for the crypto classroom, it sounds like it's just something that was necessary that has happened and is evolving quickly. That's going to get to mass adoption of Web3 faster.
absolutely
Yeah.
it's single-handedly taken Ethereum from 12 transactions per second to 90.
Yeah.
In this bear market. I know that doesn't sound like much compared to like Hedera or others, or Solana, Avalanche, but you got to remember those are, although public blockchains, those are VC-backed companies where a lot of the tokens are held by the founders. It's more of a company vibe than Ethereum.
Yeah.
Ethereum is 100% volunteers for profit.
Yeah.
Vitalik and company, Gavin Wood, all those guys, they gave away 90% of the tokens.
Yeah.
You know what I mean? Like it is a public thing, public good even. So the fact that a community of strangers has scaled this thing almost 6x with layer twos and zero knowledge is pretty impressive.
It is.
We will feel the benefits of that this bull market when we start having a few thousand layer twos all doing different execution of everything, and Ethereum's just storing data. We could easily get up to 1,000 transactions per second.
Yeah.
And then the next level of scaling, I don't know what it looks like, but once we hit about 100,000 with Ethereum, that's what Visa can do. And that's a few 100 million users. And that's really the goal. We're still like not even at broadband yet. Really, that's how slow this stuff is.
Yeah.
People don't understand and appreciate how early we really are.
Yeah.
There's so much that needs to be built and done.
Part of the excitement.
It is part of the excitement. We're exceptionally early, and
For those who are, have the courage to jump in and, take a piece of it, likely will be happy down the road.
yeah, and really the only winner of this invention is Ethereum, I think, because 1,000 layer twos competing for their own uniqueness of what computations they do better. And I just feel like it's going to be a very nuanced niche thing. And everyone's going to just be competing for the same developers, the same entrepreneurs. In reality, all the builders want is Ethereum. They just want their shit on Ethereum. That's all. If they can get 20 extra TPS here, that's just a decision. And literally more layer twos are being built every day. So it's like, but when they build something, if they choose Matic, if they choose ZK Sync, if they choose CeeLo, there's so many. Whatever they choose, they're all still using ERC20 tokens, which at the end of the day ends up in Ethereum capturing value.
Yeah.
They're going to, the layer twos are paying gas to Ethereum to store these bundles of proofs, right? That's what they're doing. So Ethereum wins. No matter how many layer twos there are, that's just more users, more gas being submitted, more revenue for Ethereum. And the more revenue, the more ether they burn. They're deflationary now. So we're just literally every day a layer 2 gets built and someone builds something cool and brings users on, we get more ether burned. So it becomes the supply goes down.
Yeah, Ethereum wins.
The layer 2s might win.
Right.
And we have some of them, some of the first movers that I really like are Optimism, Arbitrum, and Matic. Outside of them, and it's a small piece of our allocation, I don't see any of them really capturing a lot of value. I think they'll do a lot of valuable things. I just don't think it'll reflect in the token price.
Yeah.
I think they'll be very valuable projects, they'll be exciting, whatever, but they're not going to get the multiples that I think Ether will.
Yeah.
So,
all right.
Zero knowledge, scaling Ethereum seamlessly, very exciting.
Thanks. It's fun.
Yeah. Until next time, guys. Thanks for tuning in and learning about zero knowledge.
Thank you.
It's your boy JT Knows Things, and I'm back to give you those sexy disclaimers. Everything in this cast cannot be interpreted as financial advice, legal advice, accounting advice, and pretty much any other advice that you may or may not be gleaning from the episode. We are simply documenting all of our research for an educational purpose only. We thank you so much for tuning in and your support. And until next time, see ya.